We have all learned laws of exponents in grade 8, and it was something like this, that if a raised to power of n multiplied by a raised to power of n, then it is equal to a raised to power of m plus n. Of course, a should be a positive real number, and m and n can be any integers. It can be positive integers, it can be 0, and it can be negative integers. And then the next law of exponents was a raised to power of m whole raised to power of n is equal to a raised to the power of m multiplied by n. The third one was a raised to the power of m divided by a raised to the power of n is equal to a raised to the power of m minus n. And the last one was that a raised to the power of m multiplied by b raised to the power of m is equal to a multiplied by b whole raised to the power of m. This four laws of exponents we learned in grade 8. Now a can be positive real number, a is positive real number, and b is also positive real number, b and a both. Now the same laws of exponents can be extended for when m and n are rational numbers. So it is true for when m and n are integers, and it is true when m and n are rational numbers as well. They can be rational numbers also. For example, 2 raised to power of 2 by 3 multiplied by 2 raised to power of 1 by 3. Now this is equal to base is same, so 2 raised to power of 2 by 3 plus 1 by 3. This gives you 2 raised to power of 3 by 3. That is equal to 2 raised to power of 1, that is equal to 2. Right? This is 3 raised to power of 1 by 5 whole raised to power of 4 is equal to 3. It is of the form a raised to power of m whole raised to power of n. So this is equal to a raised to power of m multiplied by n. So from this you get 3 raised to power of 1 by 5 multiplied by 4, that is equal to 3 raised to power of 4 by 5. In this one you have 7 raised to power of 1 by 5 divided by 7 raised to power of 1 by 3. The two bases are the same, therefore 7 1 by 5 minus 1 by 3, right? So when you take its LCM, the LCM is 15, and it is 3 minus 5, that is 7 raised to power of minus 2 by 15. The last one is 13 raised to power of 1 by 5 multiplied by 17 raised to power of 1 by 5. So this is of the form a raised to power of m multiplied by b raised to power of m is equal to a multiplied by b raised to power of m. So from here you get 13 multiplied by 17 raised to power of 1 by 5. Calculate this value, 13 multiplied by 17, and you'll get the answer. So the laws of exponents is true when the powers are either integers or they can be rational numbers as well. It is true when they are rational numbers also. Okay, next important thing. When we talk in terms of exponents, in the language of exponents, then square root of a means that it is a raised to power of 1 by 2. Cube root of a means a raised to power of 1 by 3. The fourth root of a means it is a raised to power of 1 by 4. Now why it is important? It's important because of this. You have to understand that what do we actually mean by 4 raised to power of 3 by 2, or let's say in general a raised to power of p by q. That is, if a base is raised to power of a rational number, then what do we mean by that? So for this you have to understand this thing we have discussed. So from here you can clearly see that if we apply the laws of exponents, that if your base is a raised to power of m whole multiplied by raised to the power of n, right? Then this is equal to a raised to the power of m multiplied by n. So from here, this 1 by 2 means what? It is actually talking about square root, right? Had it been 3 by 3, it means that it's talking about cube root. Had it been 3 by 4, it means that it's talking about the fourth root, right? Had it been 3 by 5, it means that it's talking about the fifth root. Okay, that thing is clear. Now, applying this particular law of exponents, you can clearly write it like this: 4 raised to the power of 3 and then multiplied by 1 by 2. Fine, because when you apply this law of exponent, you'll get back this number only. Okay. Now, 1 by 2 means what? You are talking about the square root, right? We are talking about the square root. So, square root of 4 raised to the power of 3. 4 raised to the power of 3 means what? It's actually 64. 64 means what? 8 squared. So 8 squared, square root of 8 squared means what? 8 multiplied by 8, you take the square root, you'll get 8. Okay. So in general, you can see here, it's actually when you are taking this particular case, then actually you are talking about if your number is of the form a raised to the power of p by q, then it is actually equal to take the qth root and then a raised to the power of p. This is important, right? First you are taking the square root, sorry, first you are taking the power, that is this particular number, and then you are taking the square root or the qth root, sorry. Now there is a second scenario. The one way to look at this particular number is this, and another one is this one. Here in this case, we can write as 4 raised to the power of 1 by 2 whole raised to the power of 3. Both these two are actually the same thing. In this case, we have actually first transferred the this p as a power of 4, and then we have taken the square root. But in this case, we are first taking the square root, that is 4 raised to the power of 1 by 2, and then it is whole cube. So when you take the square root of 4 raised to the power of 1 by 2 means what? Square root of 4. So square root of 4 whole raised to the power of 3. Square root of 4 means what? 2. 2 raised to the power of 3 means what? 8. So ultimately you are getting the same answer. In this case, first you are taking 4 raised to the power of 3 and then you are taking the square root. But in this case, you are first taking the square root and then you are taking the cube. Ultimately, you are getting the same answer. So when you talk in general for this case, it's actually what? First you are taking the qth root and then you are taking the whole to the power of p. Here, first you are taking to the power of p and then you are taking the qth root. Ultimately, you are getting the same answer for this general condition number. So it means that we can say that, if I remove it here, we can say that a raised to the power of p by q is equal to this. That is the same thing. That is, either first you take a raised to the power of p, then find the qth root, or you take first the qth root and then find the raised whole to the power of p. Both will give you the same answer because it is based on a law of exponents that says that a raised to the power of m whole raised to the power of n is actually equal to a raised to the power of m multiplied by n. From here, the whole thing gets cleared using this law of exponents.